This video is for class 9 physics, and today's topic is some consequences of liquid pressure, where P equals to H rho G. We have derived this formula in the previous video. Okay, so we are studying some consequences, okay, of liquid pressure, and this particular formula will explain the consequences. Number one, in seawater, the pressure at a certain depth in seawater is more than that at the same depth in the river water. The reason is that the density of seawater is more than the density of river water. Okay, let me try to explain this. So suppose we take a beaker, okay, and in this beaker suppose we pour some amount of seawater, suppose seawater, right, seawater, and we take another beaker, and in this beaker we shall pour some river water. So this is river water, right? So suppose there is one object here at a depth of suppose 10 meter, and we have another object here which is also at a depth of 10 meter, right, which is also at a depth of 10 meter. So which object 1 or object 2 will experience more pressure? Obviously object 1, because of the formula P equals to H rho G, because density of the seawater is more than the density of the river water, right? I hope you understood the first consequence. Let us go to the second consequence. So coming to the second consequence, the wall of a dam is made thicker at the bottom, as shown in figure 4.4. Here, this one, right? Here you can see the thickness of the wall is more here at the bottom compared to at the top. The reason should be, obviously, as we go deeper down the water level, the pressure becomes more, because again we know P equals to H rho G. So as the depth increases, the pressure also increases. So to withstand that high pressure, the thickness of the dam should be more at the bottom, So I hope you have understood this. Let us go to the third consequence. Water supply tank is placed high. In your house also, water supply tank should be placed high, probably in the terrace, or probably there is a place made such that the tank could be raised. Okay, to supply water in a town, the tank to store water for supply is made at a sufficient height. The reason is that as greater is the height of tank, more will be the pressure of the water in the taps of house. Thus, for a good supply of water, the height of the supply tank must always be few meters higher than the level at which the supply of water to be made. Okay, let me try to explain this. Suppose we need to supply water in a house, right? So when we supply water in the house, the tank should be always kept at a certain height, at a certain level, tank, right, so that water can come in with a greater force, right, with a higher pressure. I hope you understood this. Number 4, diver's suit. The sea divers need special protective suit to wear, because in deep sea the total pressure exerted on the diver's body is much more than his blood pressure. To withstand it, he needs to wear a special protective suit made from glass reinforced plastic or cast aluminum. The pressure inside the suit is maintained at 1 atmosphere. Okay, I hope you understood this also. Number 5, size of a gas bubble inside the water. It is noticed that as the gas bubble from the bottom of the lake rises, it grows in size. The reason is that when the bubble is at the bottom of the lake, total pressure exerted on it is the sum of the atmospheric pressure and the pressure due to water column. This particular line here, we had proved that in the previous video also. As the gas bubble rises, due to the increase in the depth, the pressure due to water column decreases. So the total pressure exerted on the bubble also decreases. According to Boyle's law, probably you have done this in chemistry, the volume of the bubble increases due to the decrease in pressure. That is, the bubble grows in size when it is coming up. So when the bubble reaches the surface of the liquid, total pressure exerted on it becomes just equal to the atmospheric pressure only, which is minimum, and so the size of the bubble on the surface becomes maximum. I hope you understood this also, right? You can watch videos in YouTube regarding this bubble. Okay, as the bubble goes up, the size will increase because the pressure on it decreases. Okay, so this much for this video. Thank you so much.